So this is our warm-ups for today. So our first question was 12 plus negative 28. When you're adding a negative number, what is that the same as? Subtracting. So Kevin, can you tell me what 12 minus 28 is? What is it?
16.
You're close. What are you forgetting? Which one's your bigger number?
12.
Well, 12 is the positive number, but in the total of the grand scheme of magnitude, right, 28 is a bigger number or further away from 0. So since it has a negative, it stays with the problem. So we're going to have negative 16. So thank you. Nice job. Next up, does anybody want to try number 2? Yep. How did you get that?
I can't explain that as well.
So again, you are really close, but you're forgetting something as well. Taquan, you want to try it?
18.
Now, how did you get that? So you guys both ended up with subtracting a negative is the same thing as adding a positive. So these both switched to plus signs. You changed them both to subtraction signs instead of plus signs, and then that's why. But 18 is our answer because that turns into being a positive. Are you guys okay with this part so far? Okay, number 3. Does anybody want to do this one? Yes, ma'am? Can you tell me how you got that?
Squared 4, got 16, squared 2, got 4, then 16 squared.
Okay, nice job. Okay, you ready to do the next one? Okay, so I'm going to read it real quick. Oh, I'm not going to read it. Let's go through the spots. Okay, so you told me the final answer. So what is 2 times 4?
8.
What is 2 times 5? What is 2 times 6? And what did you tell? Oh, let's rewrite that, Jenkins. 12. And then what did you tell me it was? 30. Okay, thank you guys who have volunteered so far. I'm going to read the next one before I ask for volunteers. So 2 times a number minus 4. Does anybody want to do this one? Let's go over here. Yes, ma'am?
2x minus 4.
Yep, that's right. 2x minus 4. So anytime you have something that says a number, remember we represent that by a variable, and that can be any letter. There's a few letters we try to avoid, but generally we can go with like A, N, X. All those are really good good letters to represent with. Okay, the next one, 9 more than 8 times the number. Yes, sir? 8n plus 9. Okay, thank you all for volunteering for that portion. Okay, so at the top of your page, it already tells you the section 1.1, finding and describing patterns. But we have a little box or a little thing that says OBJ, your objective. Your objective today is to be able to find patterns and make predictions. So next to that OBJ, you're writing that to find patterns and make predictions. So now if we have all of these and you see how many sides they are, we saw that we had 3, 4, 5, 6. How many is the next one going to have?
7.
Does anybody remember what we call a 7-sided figure? Octagon goes with 8. This one I think is septagon. So you guys had it. I feel like that one's the trickiest one to remember of all of them. But so we have a 7-sided. So how many will the next figure have? 7 sides. So for that one, we're adding 3 to previous number. Can somebody else tell me what the next number is? Yep, Kevin?
21.
So the next one's going to be 21. After that, we have the one as 1, 4, 9, 16, 25.
It's going by odds.
So you're adding it by starting with which number?
1.
So if you add 1 to 1,
Oh, that's 2.
but if you're saying you're starting at 0, then technically that could work. 0 plus 1 is 1. 1 plus 3. So I wrote mine when I did that is I wrote adding by odds starting with 3. Now, Elise, did you have your hand up, hon?
Yeah, I was going to ask, is the answer 47?
For the next one, you're close. But it's not, you're off by just a couple numbers. There's another way to describe these numbers. Yes?
Is it like the square, like 1, 2, 3, 4, 5, 6?
It is. It's the squared numbers. That's the way I recognize these. We know these as perfect squares. 1 times 1 is 1. What times what turns into 2? What times itself equals, oh, I told you, sorry. What times itself equals 4? 2. How do we get 9? Yep, so it just continues on. So you know you have 5 squared, 6 squared, So the next one's going to be 7 squared. And what's 7 squared? 49. So you're just off just by a couple, but you're really close. So 49 is going to be our next one. So if you write this, it's going to be the perfect squares. Okay. Ooh, I'll pause. So you said if we added each number to itself, so your first number was 1, and then you added 1. So you got 2. And then you added 2. And you got 4. Okay. You added 4. Works great for me. We don't have to continue on. You see you're going to add 8 here. So this is increasing. It's getting bigger. And he's not adding by a constant amount. Another example of this is our last example. 1 squared, 1, and then 2 squared was 4. 3 squared was 9. That didn't increase by a constant amount either. Does anybody else have one they want to share? Are you guys okay with their examples? Or mine and his, I guess. Okay. Just describing it. So, what's happening to this circle? Yes, ma'am?
It adds on a section to each pod.
Yep, we're adding on a section to each pod, right? So we see this one's 2, 3, 4, so we know the next one's going to be, and we're going to continue on from there. So it's dividing it into equal parts. The number of equal parts into which this circle is divided is increased by 1. What's happening in the second one? Anybody? Yep, Kevin?
The dark spot on the sun is decreasing in height with each one.
So that's a good way of putting it. There's another word we can use, but you're describing it. It's a word that I think sometimes can be forgotten easily because we don't use it a ton. So what is another way to tell this direction? Do you have it, hon?
The dark spot rotates to the left.
Rotates to the left. That's okay too. There's another word. Let's go. But have you both of you answered questions yet? Or Rajane? Counterclockwise. So all of those are acceptable. I chose counterclockwise. To the left is pretty good description. The other one was pretty good, but you just want to make sure you're clear on which side it's going to. But we're going to go with counterclockwise. So I put the shaded triangle moves 1 space counter clockwise. Okay, after that we have 2 more to look at. On number 6, can anybody see what this pattern is? Yes, ma'am? We're adding by 4. So, plus 4, plus 4. So each number is increased by 4. Okay, after that, does anybody know what's happening on number 7? I know 7's really low, so I'm going to change my color, and I'm going to write 7 over here so people in the back might be able to see it a little bit better. 1 second, sir, and then you can go. So we'll go here. 7's being moved here so you can read it. So how did you describe that, sir?
Subtract 5.
Subtract 5. From this number. Using these symbols, what shape do you figure do you think is going to come next? We see our first arrow goes up, our second arrow goes to the left, our third arrow goes down. What's our next one going to go to? To the right. So you put in, say it one more time.
321 and 641.
So that is correct. How did you get those?
I did times to that.
So you times it by 2? So that is exactly what I did as well. So times your number by 2. So you see you have 6 times 2 is 12, minus 1 is 11. 11 times 2 is 22, minus 1 is 21. 21 times 2 is 42, minus 1 is 41. And so you continue on. Did anybody else find another way to describe this? Kevin?
I noticed that it increased by 5, and then kind of went to 20 and 40 and 80, and kept increasing.
Yep.
Greater.
And in this case, it started with 5 and then it increased 2 times the number it was increasing by, right? So it started by 5, you multiply it by 2, increased by 10. 10 times 2 is quite 20. 20 times 2 is 40. 40 times 2 is 80. And you could write it that way as well. Those are the same 2 ways my last class did it too. Nice job, guys. After that, we have B. Did anyone? Yes, Elise?
Minus 14.
Minus 14. These are big numbers. And that can be tricky if you don't have a calculator with us. What I always end up doing is I do my little side math here. Borrow the 1. We sign. And then we end up with 14. So you see that subtracting 14 each time. And then can you tell me what the next 2 numbers are, hon?
241 and 227.
Exactly right. So because of how big those numbers are, I think those were decently challenging for these problems. But nice job coming up with those answers. Record. Okay, so Elise, what'd you find?
Add the number right next to it. 1 plus 1 is 2, and then you plus the 2 by 1 makes 3, and then you keep on doing that. Going down like 3 plus 3 is 6, and then 6 plus 4 is 10. It's kind of going down kind of like that.
So do you guys see what she's saying with that? So you're adding 2 plus 2, and you get 2. You have 1 plus 2 is 3. 2 plus 1, 3. 1 plus 3 becomes 4. 3 plus 3 becomes 6. 3 plus 1 becomes 4. And the 1 continues down. And you continue over until you get to the bottom row. And we can do infinite number of rows with this. Did anybody, Natalie, did you find another pattern? Is that the one you're going to show too?
I would say all start and end with 1s.
Yep, that's another pattern. So we see that you have each diagonals, I put it, oh well, so each side starts and ends with 1 to get next row. We add the 2 numbers on top. Numbers above. Okay. So, what else? Does anybody else see anything else on this one? So they told me how to describe the patterns. She told me about the edges of this pyramid. Can anybody else see anything else? Yep.
Like going down in the middle, it's like 1, 2, 3, 4, 5, 6, and all the way down.
Exactly. So here, the first one was the 1, so I'm going to highlight that. Ooh, that's rough. Let's try again. Highlighter mode. So we see that these are still rough. Sadness. Say size. So we see these are all the 1s, right? It's not much of a highlighter, is it? The second group, you see that these are the counting numbers. 1, 2, 3, 4, 5. Goes the same way here. 1, 2, 3, 4, 5, 6. So down that second row, now that you can't see it as well, as the counting numbers. I'm going to undo those writing because you can see what I did. I'll try it again. There is something special, though, about every row we have. So you see it's the 1s rows, the counting numbers. We call these something else, too. Does anybody know what those numbers are? They're harder to find in my mind to see that connection. I just wasn't sure if maybe you guys did. So we call these triangular numbers. So if you look at this row here, and you're building triangles, I'm going to bring them up here so you can see it. So right here with dots, right? You have 1. Your next triangle that you can form needs 3 dots. To get another triangle after that, you need how many? 6. You're going to add another row. And that's how we get those. And the one after that actually is what's going to build a pyramid. So if you're actually stacking balls to create a pyramid, and they continue on to create different shapes. So that's pretty cool. So for number A or letter A, your answer was going to be to add the 2 numbers that provide this number and then 1 On the borders, those are good. So if you wrote any of the stuff on the side, that works for me. And how many different patterns? Well, the ones we just discussed work. So you could talk about the ones, the counting numbers, and then the triangular numbers.